I'm seeing people really, really looking at this space, and we think we'll make it as economically viable as solars.
Greetings, Earthlings, and welcome back to your podcast, the show where we explore what technology and processes we can employ to accelerate certain energy to go where we want it to go so that we can maximize it and use it. On today's show, we're going to talk about small wind energy. This is not the big turbines that you see with big farms out there in the world, but small modular devices. And I'm really excited to bring you this topic because I've covered it a long time when I was at NPR and PBS before I moved into public relations. And then I represented a few companies there as well back in the day, when clean tech wasn't as cool as it is today. But before we get into this topic, the requisite podcast logistics. Now, if you're listening to the show and you've actually listened to maybe more than 3 episodes, I wager to guess that you enjoy what you're listening to. So if you would please do us a favor, open up your podcast app right now, scroll through the show, and give us a rating. You can just leave us a few stars. You can leave us a few comments as well. Whatever you choose, this gift to us is going to help tremendously as others come to find us. If you're feeling financially generous, you could join the Patreon page and contribute there to help support some of the costs of putting on this podcast. Or you don't have to do any of those things because, as you know, we appreciate you just the same. When it comes to small wind energy, I'm going to wager a guess that most of you don't have a good understanding of what the market is and what the options are that are out there. And you would not be to blame because it is an industry that has been small and it's kind of under the radar, actually, unless you're someone like me who's kind of followed it because you found it interesting and you reported on it. And the reason I find it so interesting is because if you think about it, the sun shines during the day, the wind blows at night. And if we want to maximize the renewable energy resources around buildings, no matter where they are in the world, we get a chance to capture that wind resource. And when we can, then you're generating renewable energy more frequently throughout the day. And that's just going to be better overall for the resilience of the building from an energy standpoint, and potentially the resilience and more renewable energy mix going into the grid. And like I said, startups have come and gone from this space, and they've struggled where I think our guest today is going to succeed. Her name is Erika Boeing. Boeing, like the aircraft manufacturer, which is going to make it really easy for you to remember her name, because part of the R&D work that she has done on her turbine system is to mimic airfoil design and optimize that design. Boeing, airplanes, small wind. That's how you're going to remember it. And her company is Accelerate Wind. She's the founder and CEO. And before she founded this company, she was a Fulbright fellow. She was a mechanical components intern at NASA. She was a project researcher for Project Drawdown. She has a very strong pedigree beyond just the engineering background and the intelligence that is her natural talent. So we started our conversation around Accelerate Wind through what brought her into this space.
I think it's an untapped resource and one that gives people a lot of on-site control over their energy and also connects us a lot more to our energy sources and where they're coming from. And so I'm really excited about bringing that forward.
Awesome. Thank you. And you know what? I think unlike solar energy that's really matured over the past several, decades, you've got these two categories: big centralized utility scale solar farms, and then you've got the distributed scale on buildings and or ground mounted, but still sort of adjacent to a specific building where that energy is going to be used. But when it comes to wind energy, all we see are these big turbines. So why do you think small-scale wind energy hasn't grown like solar in the past couple decades?
Yeah, that's a great question. I think there's a couple of reasons for that. The biggest one at the highest level is just cost. So most small wind turbines to date, especially on the rooftop scale, just haven't paid themselves back within their lifetimes. And as opposed to solar, you saw that really increasing drastically as soon as it hit kind of grid parity, or hit that like 4 to 6 year payback time in a lot of places, and wind just hasn't gotten there. And so that's been our big mission, is to try to help with that.
Okay. And like it also seems like with wind, especially like in urban settings, like we've all walked down like the alleyway between buildings and it's a wind tunnel, and in the city you're like, I'm not going down that little street because I know it becomes a wind tunnel and my hair is going to get ruined. So there's obviously a lot of wind around buildings, but how much of it is there? How do we tap into it?
There's a lot of wind around buildings. It is cool because almost everybody's felt that experience going through a city and kind of walking through an alleyway and being kind of knocked off their feet by the wind. But it's unpredictable sometimes where that wind will be. But what we figured out at our company about 5 years ago, and have been adapting since then, is that the wind will naturally speed up at the edges of buildings or the sides of buildings as well, which is what you see in an alleyway. And so you kind of get a concentrated wind flow that you can take advantage of right in that area.
Okay, so tell me about your technology and how you're taking advantage of that wind, and how you can really predict where that wind is coming from and where it's going to go.
Yeah. So yeah, our technology is completely designed around that. That was an insight that I had when I was doing a Fulbright over in the Netherlands and trying to figure out how to use my engineering talents to affect sustainability. I realized that the speed up effect happened and was like, hey, this is pretty significant. Can we figure out how to use it? And now, 5 years later, after a lot of research, we found an economical way to harness that wind right at the edges of roofs. We found that it's easiest to do that on flat roofs. And so, particularly commercial buildings are a really good market for this. But we're not the first people to have come up with that concept. There's been a number of other companies who've tried to capture wind at the edges of roofs before. And the problem that they run into is that you do see an increase at the edge, but typically it's a mix of fast and slow wind speeds. And just because of the way that the wind flows over a building, you would still need a kind of tall tower to capture the wind. And that's just really expensive. But what we've figured out is that there's a range of airfoil shapes that we've patented that sit at the edge of the roof, and actually, if they're the right shape and the right range, they can draw that faster wind down to the edge of the roof so that you can capture it right at the edge rather than needing that tall tower, which doesn't make a lot of sense. And so that's what our technology is based around: is edge of roof wind capture using our patent pending technology to guide the wind towards a turbine.
Okay, so that's cool. So can you break it down a little bit more for me? What's happening when the wind goes over a roof? And you mentioned the speed up effect, I think is the phrase that you use. Describe that if you could just sort of illustrate or paint a picture for us when wind goes over a build around a building and over a roof, what's happening?
The building will block the wind, and on the vertical face of the building, you'll get a really high pressure because the building's blocking the wind. And then at the top of the building on the roof, you get a low pressure. And that pressure difference causes the wind to speed up in order to get over the edge. The reason that it's hard to capture that wind that's accelerating is it doesn't happen in an even way, so that it's highly concentrated right at the edge. And so that's what our technology has been focused on: is taking the wind that the building is already accelerating and then drawing it down so we can capture it right there.
Are you drawing down the speed, or are you drawing, what do you mean by that?
If we want to get technical, from a technical perspective, the problem with flat roofed buildings is that the shape of the roof causes what's called flow separation, where you get kind of like dead wind right at the edge, and then the faster wind kind of like sails up and over. Um, but what we do, we have a smooth modern airfoil, and that will cause the wind, also kind of like an airplane wing, to stick to the faster wind to stick to the sort of airplane wing as it goes over the edge, so that we can capture it. Does that make sense?
Yeah, it's like a metal rounded cap that you're putting around the top of the roof,
Okay.
and then you've got your turbines above that in rows. And so what you're doing is the wind is going up the roof, facing that way that cap is shaped. It sort of keeps that wind close to the cap, right?
Yeah,
The way it's shaped, it kind of like gets it to cozy up there, and then travel across up into your turbine.
exactly. So yeah, you get this concentrated high speed wind flow right above that cap. And then the turbine goes right there so that we can capture that energy.
Okay, that's cool. And what do the turbines look like?
They're what people are commonly referred to as vertical axis wind turbines. Except for we actually flip them on their side, so that it's kind of a long cylinder stretched along the edge of the roof. And then there's 6 kilowatt modules of turbine rotors. So just like solar, you can install any number of modules depending on how long the roof is and how much power you want to produce. And but that 6 kilowatts we found is kind of a sweet spot in terms of costs coming down. And so by having something long that stretches along the roof, we're able to get a much more affordable turbine from a overall system components standpoint.
You said these are 6 kilowatt modules, right? Um, and how much energy would you anticipate that one of those turbines could generate, say, in a day or a given time frame?
Yeah, so it super depends on where you're at, because wind is variable. But a good metric is that is using that it has about a 20% capacity factor, and that's a generalization, but it's a good metric. And so that means that on a typical building, a 6 kilowatt turbine, um, you would have maybe 50 to 200 kilowatts of a total installation if you're filling up the whole roof space, and then those turbines would be generating the equivalent of like full power 20% of the time.
Okay, and then of course probably makes the maintenance easier because you've got these modular components. The whole thing doesn't go down if one piece isn't working right.
Exactly. We're trying to time everything with because these will probably in most cases be installed alongside solar because they don't compete. They're intentionally designed to be a complementary solution. And so in those cases where it's installed alongside solar, you'll have annual maintenance most of the time. And so we're trying to develop it so that it's on the same maintenance cycle as solar to keep costs low on maintenance. And so yeah, if you have one that shuts down, it's not going to kill the whole thing.
And that makes sense too to sort of couple it with solar because I mean, from a general perspective, we think about the sun shines in the day and the wind blows at night.
Yep, exactly. So yeah, there's the time of day thing. And then I was actually really inspired by solar taking off when I started the company and was looking at commercial buildings specifically and saw that like most commercial buildings can't produce their energy demand entirely with solar. And so most of these buildings are looking for additional solutions if they want to hit the net zero targets or whatever decarbonization targets they have. They usually need something else. And so I saw this as a way of enabling that, not competing.
I like that. I like that. And couple it with some energy storage, and then you're good to go.
Yep, I think that's as time goes on. I think that'll be more and more common as a solution. Just solar wind storage combined together.
We hear a lot about with the climate crisis, increases in extreme weather, and those types of we do expect to have increases in extreme weather. So how would these building owners protect their investment if a storm was coming their way?
Yeah, that's super important. We've spent a lot of time focused on kind of reliability of the turbine. And so we're designing it for a certification standard that sets the load cases that you need to be able to withstand in different weather environments. The small wind certification standard, IEC 61400-2, if anybody wants to know. I
Now
spend
we
my
have to put
days
that in the show notes.
I spend my days doing these things. And, um, um, but yeah, the that standard sets the wind class that you're eligible for. And right now we're designing in a lot of cases for up to 120 mile per hour winds, and really focused on kind of that being the max scenario, which will cover us for a lot of cases at least.
Hmm. Hmm. Okay. Okay, cool. So then, when I think about small wind, like we talked about it a little bit at the beginning of the interview, it's kind of had its ups and downs, right? And like you mentioned ROI or payback as being one of the things that hindered some of these early designs or efforts. Are there any other aspects to past efforts that you've learned from?
Yeah. So ROI is one for sure, but then also reliability. So it takes a long time to develop a good wind turbine. A lot of detailed design work, and testing and iteration is just a complex system. And so I have learned from a lot of other small wind turbines that came before us. When we got started, we saw that was a main failure point, was pushing things to market pretty quickly, when maybe they weren't ready yet, and like really needing to take the time to think about the system level design. And so we've been very conscientious about that. As we design for certification, we've also been working with National Renewable Energy Lab, in order to make sure that we're really taking the lessons learned that a lot of people there have absorbed over their 30 years of working there, and developing something that it will be robust, as we go to market. So we've had a lot of government grants that have let us kind of take those first steps, and really carefully design the turbine. And being able to predict how much wind you're going to get in any particular location, um, is a challenge. And then also to put the turbine on maybe a part of the building that looks cool. And so it's like an aesthetic decision rather than like a power output decision, and then those inevitably underperform. And so we've been also spending a lot of time on power prediction, and kind of developing a rigorous set of criteria for that.
You talked a little bit about your some of your IP is around how you designed the blades on your turbines. And obviously, I don't want you to give away any of your secret sauce. But can you tell us a little bit about what makes those different compared to what we may have seen in the past with small wind turbines?
Most of our IP is, not on the turbine blades themselves, though there's a lot of design work there, but actually in our we call it the thing you call the cap that goes over the edge of the roof. We call it our spoiler, and so we've run thousands and thousands of computational fluid dynamics models to really pinpoint the range of shapes that will let that happen. And we found that there's a few key features, and ranges of shapes that will let us draw the wind down to the edge of the roof so that we can capture it there. And so our patent is, focused on, those ranges of shapes that kind of enable the edge of roof to be an economically viable solution.
Is there a way that you've designed the turbine blades that are different compared to what we might have seen in the past?
So yeah, if you look at a picture, of the turbine, it's a lift driven vertical axis or cross flow wind turbine, which, we, have by far found to be the most economical. And then a lot of the design is more in the system level optimization of how we have coupled the rotor, and sized the drivetrain components. And then we've worked on the blade side. We're working with, a company who has a lot of experience developing, this particular type of rotor, and, doing a lot of experimental testing work to validate what the proper blade shape is. And so we've done a lot of experimental testing on that.
Okay, it sounds like you've been extremely thoughtful and thorough with your design work. to create something that's really going to be useful. So speaking of the market, what do you predict for this category that your technology serves, this small distributed wind?
Yeah, I'm seeing a huge amount of interest right now, which is really exciting. Like, I've seen a huge interest from commercial customers that was there, but not nearly as strongly before. So I'm seeing people really, really looking at this space. And uh, we have a technology that we think will make it as economically viable as solar. So I over the next 5 years, if I could if I could predict, I see a lot of scale up specifically on commercial buildings. Kind of you're looking at like the warehouse factory, like retail type spaces where you have like long flat roofs where it can be made economically viable.
Yeah, those big flat roof warehouse type commercial buildings seem to have a lot of potential. I
Hmm.
I always try to play a game with myself when I am flying into a city, and I try to count how many of the flat roofs around the airport have solar. And if I can at least find two, like we're doing good. It just seems like a huge missed opportunity. And I'm sure there's a lot of market factors that go into why those buildings still don't have solar, even though like it seems like a no-brainer. But anyhow, so please tell me how you want to couple the wind and the solar resource together for people who are installing solar, and how they might implement in your product.
Yeah, so that was another really, really intentional part of our design. Is we looked at costs of other small wind turbines and saw that a huge percentage of the costs were actually soft costs. So things like customer acquisition, installation, permitting, financing, all of those things, because other wind installers would have to spin up a whole new like department in each market, that it tends to be really expensive at the outset. But solar installers are already very good at this. They've been working on refining those processes for a decade or two, and they tend to have their kind of regional teams deployed. And we found a lot of them are looking for additional solutions, especially now that the market is looking for it more, and the market's kind of consolidating for solar as well. So this allows them to increase their average deal size by at least 25%. And so it's a really nice incentive for them to do what they're already doing and just build a bigger deal. And so we've intentionally designed our turbines so that they can be installed by staff that solar installers will already have out on a job site using tools that will already be there, to make that as seamless as possible for them to kind of integrate into their existing practices, so that we can use the fact that they're really good at doing installation, and so that we don't have to spin up new teams in every place.
I think you're really smart to do that because if I put my my startup PR hat on, the companies that I have watched really succeed are ones it's not just about cool new technology, but it's usually coupled with an innovation on the business model or market penetration side that is the 1-2 punch that these companies need to rise above all the noise. And we talked a lot about commercial buildings. Do you foresee any more residential applications for your work? And do you anticipate that this technology could be viable for you know countries in the global south or in developing regions?
I guess I say commercial, but really the restriction is more on like it really works best with flat roofs. So that could be multifamily apartment buildings or any building that has a flat roof, that we could couple to. That's what we're intentionally designed for now. And that would also include in the global south. This is not our focus, but we've talked about could we make a containerized version that like installs on top of like shipping containers as well, and could be set up in more remote environments. And I know that there's huge opportunity in general in the global south, and I am personally excited about the potential for impact there. But we also know right now, like we've been kind of focused, and we know that like we understand the US market, that is probably step one, and let's build a reliable product here, and then I we plan to expand globally, and I'd be really excited about that.
Well, perhaps in the future. You got to start somewhere.
Yeah, for sure, for sure.
So, okay, great. Where's the company now in its development, and what can we expect in the next few years?
So I think we're at a really exciting point. We've done a lot of prototype testing at Argonne National Lab, and then right now we are testing a half-scale version of our turbine at a third-party test site in Utah, and really trying to get thorough data to make sure that it's absolutely safe before we put it um, on pilot buildings. We're going to over design our first several pilots just to be super safety conscious, and so we're measuring all that data now, and then also working on our like plans for pilots and rollout. So we're anticipating a number of pilots and over the next 1 to 2 years, and that really being our focus, so we can get that data in the real world, and then scale up from there. But it's exciting to be at that phase after a lot of like R&D slog, and I think it's well timed with the market as well when we're seeing a lot more interest in distributed wind right now. So I'm happy about that.
So, Earthlings, what do you think? Small wind energy. I think it's pretty viable, more viable now than it's ever been. And it's definitely a nut we have to crack eventually, because otherwise we're just letting this lovely renewable resource of wind that is found everywhere around the world just, frankly, go to waste. And I think we get a chance to figure out how to use it. And Erika has spent a tremendous amount of time and effort on her R&D to deliver something that she thinks is going to work. And frankly, how many of us have seen startups come and go because they have a shiny new product and but they didn't spend enough time in the development process. So it looks great, maybe it works, probably doesn't. I mean, if you work in the renewable energy space, you probably have witnessed a lot of roadkill along the way from people who did not take the time to do it right the first time. Like a friend of mine's carpenter dad used to always say when we were kids, if you don't have time to do it right the first time, when are you going to have time to fix it? And frankly, I think that we have seen a lot of technology companies come and go and frankly probably get more funding than they deserved because, but they didn't spend enough time on the R&D. So I really appreciate Erika for taking her time to build this technology and do it as appropriately as she deems fit. So keep your sensors pointed to Accelerate Wind. We're going to be watching them as well, and we wish them the best of luck on their entrepreneurial journey. If you've got a building that you want to test the technology out on, hit us up on social media or contact Erika directly on LinkedIn and give her your support. Until then, Earthlings, thank you for joining us, and we will see you again on another turn of this beautiful blue-green space flower we call home.